Hello again. We're going to look at some things in section 5.3 today. So I wrote down the couple of equations that are most significant in this chapter, or in this section of the chapter, I should say. And what we're looking at is trying to find the cosine of an angle that we don't know from the unit circle, but we know that it's the sum of two other angles or the difference. So for example, if I wanted to find the cosine of 75 degrees, so if we look down here, this is an example of what we're doing. Well, remember, I can't mix inside of the parentheses and just sort of take it out of the parentheses and do some arithmetic or algebra. Whatever's inside the parentheses has to stay inside the parentheses, unless I have an identity. So for example, cosine of 75 is not the same as cosine of 60 plus cosine of 15. Cosine of 75 is not the same as cosine of 30 plus cosine of 45, right? And we can prove that to ourselves if we just take our calculator and say, okay, what is the cosine of 75 degrees? 0.2588. Now let's think about what is the cosine of 30 degrees plus the cosine of 45 degrees, 1.57. Those are not the same thing. So we can't just break a number apart and separate it into two separate cosines and add them. So the way that we would do it is we would say 75 degrees. Instead of separating it outside, I could say, well, the cosine of 75 degrees could be rewritten. I can stay inside of the parentheses, and I could write that as the cosine of 60 degrees plus 15 degrees. Or I could write it as the cosine of 30 degrees plus 45 degrees. And these two angles are on the unit circle. So I could take these two angles and call the first one u and the second one v and plug it right into this equation of cosine of u plus v. Okay, now I do want to point out that when we get to radians, you know, it's pretty easy to say 60 plus 15 is 75, but when we get to radians, a lot of times we're going to need to get a common denominator. So I just want to remind us that we did this at the beginning when we first started sine and cosine, that all of our radians of the special angles on our unit circle, they all have a common denominator of 12. So it's worth it to remember that pi over 6 is 2 pi over 12. And 45 pi over 4 is 3 pi over 12. And pi over 3 is 4 pi over 12. Because those are going to come in handy as we do this section. And you could go around the unit circle and put all of the numbers on the unit circle in terms of 12ths if you wanted to. Okay, so number one in the assignment is sine of 15 degrees. So I'm going to try to keep these formulas over here. I had them numbered, A, B, C, and D, and then do some of the homework problems with you. Okay, so sine of 15 degrees. Well, that's not on my unit circle, so it's not one of the special right triangle angles. And so I'm going to try to think about what angles on the unit circle that I've memorized the sine and cosine of, or that I know how to find the sine and cosine of from special right triangles, would add or subtract to 15. So I can quickly see that 15 is 45 degrees minus 30 degrees. Or I could also say it's 60 degrees minus 45 degrees. And either one of those choices would work. So I'm going to choose this one. I'm going to do it this way. So I'm going to say sine of 15 degrees is the same as sine of 45 degrees minus 30 degrees. And those are inside the parentheses, so that's the same as sine of 15 degrees. Now, because I have a u minus v situation, 45 minus 30, I'm going to go over here and say I'm looking for the sine, and u is going to be 45, and v, right, the v is going to be 30. And so when I plug into my formula, right, it's going to be sine of u. So I'm going to do that. I'm just going to plug into the formula sine of 45 degrees cosine of 30 degrees minus cosine of 45 degrees sine of 30 degrees. And that's how you use these formulas. And then we go based on our memory of the unit circle. Sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2, minus cosine of 45 is root 2 over 2. Sine of 30 is 1/2. So root 2 times root 3 is root 6. 2 times 2 is 4. When you multiply fractions, you multiply the numerators, and then you multiply the denominators. Same common denominator, so that's root 6 minus root 2 over 4. And so that is equal to the sine of 15 degrees. Now let's try it on our calculator and convince ourselves that these formulas work. All right, so we'll put the calculator here, and we'll say, okay, root 6 minus root 2, so I'm going to do that in parentheses, square root of 6, square root of 6 minus square root of 2, and then I have parentheses around the whole thing because that's the numerator, divided by 4, 0.2588. Now we're going to do sine of 15 degrees, 0.2588. So they are in fact the same. That is the number that is the sine of 15 degrees in its exact form. Okay, number 2, we're going to look at, or number 3 because we're doing the odds. So number 3 is the sine of 75 degrees. Okay, sine of 75 degrees, so I'm going to take 75 and I'm going to rewrite it as sine of 30 degrees plus 45 degrees. And 30 degrees, so we have a sine of u plus v. So I'm going to go to my u plus v formula, and we're going to say, okay, sine of u, that's 30 degrees. Cosine of v, cosine of 45 degrees, plus cosine of u, cosine of 30 degrees. Sine of v, sine of 45 degrees. And sine of 30 is 1/2. Cosine of 45 is root 2 over 2, so multiply those. Plus cosine of 30, root 3 over 2. Sine of 45, root 2 over 2. And so we get root 2 over 4 plus root 6 over 4. And so that equals root 2 plus root 6 over 4. And that's equal to the sine of 75 degrees. Okay, and then we'll do one more. We'll do number 5 on this video, and then I'll continue on another video. Cosine of pi over 12. Okay, so we're going to think about our radians. Pi over 12. So pi over 12 could be written as 3 pi over 12 minus 2 pi over 12. So I'm going to do that. I'm going to do cosine of pi over 4, because that's 3 pi over 12, minus pi over 6, because that's 2 pi over 12. So 3 pi over 12 minus 2 pi over 12 is just 1 pi over 12. Okay, so now we're in this formula up here, cosine of u minus v. And so we know that that's going to be cosine u, cosine v. So u is pi over 4 and v is pi over 6. So cosine of pi over 4, cosine of pi over 6. And then in the u minus v formula, it's a plus here. So plus sine of pi over 4, sine of pi over 6. Okay, and I'll just move this up a little bit. We're almost done. Cosine of pi over 4, root 2 over 2. Cosine of pi over 6, root 3 over 2. Plus sine of pi over 4, root 2 over 2. Sine of pi over 6, 1/2. And so we get root 6 over 4 plus root 2 over 4. And so the cosine of pi over 12, common denominators here, I can add these fractions, is equal to root 6 plus root 2 over 4. And that's the cosine of pi over 12. Okay, and I'll do some more on the next video.